So let's perform differentiation of certain elementary functions, after which we take a couple of examples. So given that f of x is equal to a, where a is a constant, how do we find the derivative of this function with respect to x? Now the derivative of this function with respect to x, which is given as f prime of x, is equal to 0. Thus, the derivative of a constant function is equal to 0. So for example, if f of x is equal to 2, then the derivative of this function with respect to x is equal to 0. Now let's move on to 2. So let's assume that this time we have f of x equals a times x to the power n. Now the derivative of this function is equal to, first of all, you are going to drop down the exponent, which is n. You multiply that by a, you multiply that by x, and then you reduce the value of the exponent by 1. So that becomes n minus 1. So for example, if we have f of x to be equal to 2x cubed, then f prime of x will be equal to, you drop down 3, you multiply by 2, and then by x, and then you reduce the exponent by 1. So we have exponent 3 minus 1. Let's simplify this. Now 3 times 2 is 6, and then we have x to the power 3 minus 1, which is 2. So this is f prime of x. Again, this time let's assume that we have f of x equals x squared plus 3 all exponent 2. Now this is called a composite function. So this is a function in another function. Now to find the derivative of such a function with respect to x, we say that f prime of x is equal to, so first of all you drop down the 2, that is the exponent, so you have 2 times, and then you find the derivative of this expression, what we have in the bracket, with respect to x. So x squared becomes 2x, the derivative of x squared with respect to x becomes 2x, and then this is a constant, so it goes to 0. And then you multiply that by what we have in the bracket, which is x squared plus 3, and then you reduce the exponent by 1. So 2 minus 1 is 1. Now let's simplify. So we have 2 times 2x, which is 4x, and then times x squared plus 3. So given the composite function of this form, this is how to find the derivative of such a function. Now you can as well expand this expression and then try to differentiate term by term. You are going to get the same results. Now to 3. Given that f of x equals e to the power x. Now the derivative of this function with respect to x is equal to, you are going to differentiate the exponent. Now the derivative of x with respect to x is 1. So you have 1 times f of x. So you have 1 times e to the power x, and that is equal to e to the power x. Now for example, let's assume that we have f of x to be equal to e to the power 3x plus 2. So f prime of x is equal to, we are going to differentiate the exponent. Now the derivative of 3x with respect to x is 3, and then because 2 is a constant, it goes to 0. So we are going to multiply 3 by f of x, which is equal to e to the power 3x plus 2. Therefore we have f prime of x to be equal to 3 times e to the power 3x plus 2. Again, if f of x is equal to 2 times e to the power x squared. Then f prime of x will be equal to, you differentiate x squared, so you have 2x, and then you multiply that by f of x, so that is 2 times e to the power x squared. So this becomes 4x times e to the power x squared. So that is f prime of x. So to 4. Now if we have f of x to be equal to ln x, then f prime of x will be equal to, we are going to differentiate this, and that gives us 1. So that's going to be the numerator, and then we are going to repeat this at the denominator. So that is 1 over x. So for example, if we have f of x to be equal to ln 3x plus 4, then what this primarily means is that we have f prime of x to be equal to, we differentiate this, we have 3 divided by, we are going to repeat what we have in the bracket, so that is 3x plus 4. Again, if f of x is equal to ln x squared, then we say that f prime of x is equal to, the derivative of x squared with respect to x becomes 2x. So we have 2x divided by x squared, and that is equal to 2 divided by x. So that is f prime of x. 5. If we have f of x to be equal to a to the power x, then f prime of x is equal to a to the power x times ln a. So a typical example is, if f of x is equal to 2 to the power x, then f prime of x is equal to 2 to the power x times ln 2. Now let's move on to trig functions. Let's try to familiarize ourselves with the derivative of some basic trig functions. So let's start off with this. The derivative of sine x with respect to x is equal to cos x. The derivative of cos x with respect to x is equal to negative sine x. The derivative of tan x with respect to x is equal to sec square x. The derivative of cosec x with respect to x is equal to negative cosec x times cot x. Now the derivative of sec x with respect to x is equal to sec x times tan x, and then lastly the derivative of cot x with respect to x is equal to negative cosec square x. So let's move on as we consider some more complex examples considering the derivative of trig functions as well as the basic differential rules we considered in the earlier section. So let's find the derivative of the following functions. Now we have 10 questions in all. Let's try to solve these questions. So for question 1, we have f of x equals 5 times e to the power tan x. We are going to find the derivative of this function with respect to x. So to do so, we have f prime of x to be equal to, first of all, we are going to differentiate the exponent, which is tan x, with respect to x, and that is sec square x, and then we multiply that by f of x. Now we have f of x to be 5 times e to the power tan x. Therefore, we have f prime of x to be equal to 5e to the power tan x times sec square x. So that is f prime of x. Now let's move on to 2. So for question 2, we have f of x equals ln sine 2x. Now the first thing we are going to do is to differentiate what we have in the bracket. Now, the derivative of sine 2x with respect to x is equal to, so first of all, we are going to differentiate the argument, and thus the derivative of 2x with respect to x is equal to 2. So we have 2 on the outside times, now when you differentiate sine, you have cos. So that becomes times cos 2x. So that is the derivative of sine 2x with respect to x. So for the entire function, that is f of x, f prime of x is equal to the derivative of this, that becomes the numerator. So that is 2 cos 2x divided by, we are going to write what we have in the bracket at the denominator. So that becomes sine 2x. Now we know that tan x is equal to sine x over cos x, and therefore 1 over tan x is equal to cos x over sine x, and that is also equal to cot x. Therefore, we can simplify this as 2 times, now cos 2x divided by sine 2x becomes cot 2x. It becomes cot 2x. Therefore, we have f prime of x to be 2 cot 2x. Now let's move on to 3. So for 3, we have f of x to be equal to cot 4x minus 1. Now when you differentiate cot x, you have negative cosec square x. Therefore, first of all, we are going to differentiate what we have in the bracket. So that becomes 4 times, when you differentiate cot x, you have negative cosec square x. So we have negative cosec square, and then what we have in the bracket, that is 4x minus 1. So that becomes negative 4 cosec square 4x minus 1. And then 4, we have f of x equals 7 times x to the power 1 over 2. F prime of x will be equal to, we are going to drop down the exponent, that is 1 over 2. We multiply by 7, we multiply by x, and then we reduce the exponent on x by 1. So that becomes 1 over 2 minus 1. So we simplify this as 1 over 2 times 7 becomes 7 over 2 times x to the power negative half. We can further simplify this as 7 over 2 times, now x to the power negative 1 over 2 is 1 over x to the power 1 over 2. And then finally, we say that f prime of x is equal to 7 over 2 times 1 over the square root of x. Now let's move on as we consider the subsequent questions. Now let's continue with question 5. we have f of x to be equal to cos 3x plus 10. So f prime of x is equal to, we differentiate the argument, so that becomes 3, and then we know that derivative of cos x or derivative of cos gives us negative sign, so that becomes negative sign, and then we are going to repeat what we have here, so that becomes 3x plus 10. So we simplify this so that we have negative 3 sine 3x plus 10. So that is f prime of x. 6. F of x equals 6 times e to the power x squared plus 2. So f prime of x is equal to, we are first of all going to find the derivative of the exponent on e. So that becomes 2x, and then we multiply that by f of x. So f of x is 6 times e to the power x squared plus 2. So 2 times 6 is 12. So we have 12x times e to the power x squared plus 2. 7. We have f of x equals ln x squared plus 4. So f prime of x is equal to, we are going to differentiate what we have in the bracket, and that is going to be at the numerator. So that becomes 2x divided by, we are going to repeat what we have in the bracket at the denominator. So that is x squared plus 4, and that is f prime of x. Now to 8. We have f of x equals 5x plus 2 all exponent 4. So this is a composite function. So we have f prime of x equals, we are going to drop down 4, that is the exponent. We multiply that by the derivative of what we have in the bracket with respect to x. So that becomes 5. And then we are going to repeat what we have in the bracket. So that is 5x plus 2. And then we reduce the exponent by 1. So that becomes 3. So we simplify this as 4 times 5 is 20. So 20 times 5x plus 2 all exponent 3. 9. F of x equals 5 cos 2x plus 3. So f prime of x is equal to, we have 5 times. So first of all, let's differentiate what we have here. So the derivative of 2x plus 3 with respect to x becomes 2. So we pull out 2. And then notice that when you differentiate cos, you have negative sign. So we have negative 2 sine 2x plus 3. And then let's multiply that by 5. That's going to be 5 times negative 2 is negative 10. So negative 10 sine 2x plus 3. 10. We have f of x to be equal to 3 sine 4 minus 5x. So f prime of x is equal to, we have 3 times the whole of, when you differentiate 4 minus 5x with respect to x, you have negative 5. When you differentiate sine, you have cos. So cos, and then we are going to repeat 4 minus 5x. So we have 3 times negative 5, that is negative 15 times cos 4 minus 5x. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.